Before continuing to other topics, let us learn a little about vectors. A vector quantity is often represented with an arrow on top of the quantity. In general, it is taken in 3 dimensions, as we live in a 3-dimensional world. By this, you might have guessed that the quantity have a magnitude as well as a direction. Let us assume a quantity q working at an angle alpha, beta, and gamma along x, y, and z axes respectively. It can also be represented in 2 dimensions. The only difference in 2 and 3 dimensions is that one of the dimensions is reduced to 0, and the quantity works at an angle alpha along x-axis and beta along y-axis, where beta is equal to 90 minus alpha. For 3 dimensions, the equation can be written as follows: qx, qy, and qz as the components of the vector along x, y, and z axes respectively. And the full equation can be written with the component where I, j, and k are unit vector notations along x, y, and z axes. For simplicity, the equation can be written in 2 dimensions very easily by drawing right angle triangles, where qx and qy are again the components along x-axis and y-axis. The only difference that can be considered is that the component along y-axis can be written as product of the vector the sine alpha, which is equal to cos beta. So the equation in full can be written as follows, and you can note it down, where again I and j are the unit vector notations along x and y axes. Don't feel shy to pause and note it down. After all of this, we can learn about vector addition and subtraction. Let us assume 2 vectors q and v, with qx and qy are the components of q and vx and vy as the component of v along x and y axes respectively. They can very easily be added or subtracted by adding or subtracting the coefficients of I and j to get the components of the resultant along x and y axes. Don't feel shy to like, share, and subscribe if you think that the video was really helpful. Thanks for watching.